In this video, let's work on the tests on differences between means when we have two independent samples. And recall that this is based on the conclusion we get on the test on variances, whether we assume equal variances or not. So there's going to be an association between the test on the variances and the test we're going to perform now. Now we have two cases, equal versus unequal variances. Let's do them one by one. In this video, let's focus on equal variances, assuming equal variances. Next, we're going to go to unequal variances. So let's make it like that, assuming equal variances. Over here I'm just gonna write equal. And by the way, before writing equal variances, let's understand what we're testing, and then we're gonna subdivide that test because it's gonna make more sense. So what we're testing is this: whether two groups have the same average. And let's say the groups are group 1 and group 2 that study statistics at Erasmus University, and we want to know whether the mean the mean grade for statistics in group 1 is equal to the mean grade in statistics for group 2. That's the idea. So let's do so. Under the null hypothesis, we would have that the mean of the first group equals to the mean of the second group. Under the alternative hypothesis is that the means differ from each other. It's going to be a regular two-sided test, a simple one. Now, assuming equal variances, we can subdivide this. Let's say we're going to assume equal variances in this video. So if we assume equal variances, let's see how the t-test is going to look like and what we need to know about it in terms of degrees of freedom and confidence interval. So we're doing a test on differences. We're going to use sample data for our estimations, meaning we're going to do a t-test. Let's assume that we're using a t-test because the sample size is small, since it's a university, so not that many students. And yeah, we're going to do that. So in the t-test, we're going to have differences between the sample means, right? X bar 1 minus X bar 2 divided by the standard error. And because we assume equal variances, we're going to calculate one variance only to calculate one standard deviation. We call that the pooled standard deviation, which we're going to show in a second. So we're going to have here the pooled standard deviation times square root of 1 over n1 plus 1 over n2. Hope this is visible. I have to keep the zoom out because otherwise we don't have enough space. Now, this is the pooled standard deviation. What matters here is to know how to calculate the pooled standard deviation. So I'm going to do it over here in a corner. This one, we're going to calculate it like that. First, we calculate the pooled variance. So that's equal to the variance of the first group times the number of observations in the first group minus 1 plus the... Yeah, this is becoming messy, but sorry about that. The variance in the second group, times the number of observations in the second group minus 1. All of this divided by n1 plus n2 minus 1. That's going to be our pooled variance, the square root of that. So the square root of the pooled variance is going to give us the pooled standard deviation that we're going to substitute back into our formula. And this data we have access. We have the number of observations, we have the sample means, and so on. This is how the t-test is going to look like. Let me just highlight like that. This is going to be the t-test when we assume equal variances. What else do we need to know? We need to know what to compare it to. So let's go over here to the right a bit. The t-critical value, because we're having a two-sided test in our example, it's going to be the significance level. For the sake of the example, let's say that's 5% spread on two tails. The degrees of freedom are going to be the same as here, n1 plus n2 minus 1. So we're going to have n1 plus n2. Sorry, I said minus 1, I meant to say minus 2, that's my mistake. Minus 2, and here also minus 2. This is going to be our t-critical value that we have to compare. Based on that, we would give a conclusion. For the sake of the example, what if we reject the hypothesis? Then we have enough evidence that the means differ. Simple as that. If we don't reject it, we do not have enough evidence that the mean grades between the two groups differ. That's the idea. What else is left in a test? What else do we need to know? The confidence interval. How can we design a confidence interval for these differences? Because recall, whatever difference that we have is differences between samples. They are not exactly the differences that we incur in the entire population, in the entire group of students in the Erasmus University, just on those students that we pick randomly from those groups. So to find out a confidence interval on differences, we're going to have a confidence interval on differences between means in the population that's going to give us a range. Let's say it's a 95% confidence interval. It's going to give us a range of values that's going to include the actual difference from the population groups with a probability of 95%. Hope this makes sense. How do we design this confidence interval? Well, that's based on the sample differences, x bar 1 minus x bar 2, plus minus, so we're going to have plus minus The t critical value, which we have over here, so the t critical value at 0.025, because we divide 0.05 by 2, with the degrees of freedom n1 plus n2 minus 2, multiplied with the standard error, and the standard error is going to be the pooled standard deviation, which we already calculated, multiplied with square root of 1 over n1, number of observations in the first group, plus 1 over n2, so 1 plus 1 over n2. Now that would be the confidence interval. Let me highlight that. That's the last piece that we are concerned about in this test. So we need to know the hypothesis, we need to know the case when we are using, we need to know the test, a t-test, the critical value, the confidence interval. With the same logic, we're going to replicate this for the unequal variances in the next video.